Alrighty, everyone. So we're going to be continuing on with our ionic bonding notes. If you recall, the last couple times that we looked at notes, we were looking at making our ions, and we looked at cations or our positive ions, and anions or our negative ions. So these two slides you've had previously, but they're just review. So our metals are going to tend to form cations. So those are our positively charged ions. Remember that it's easier for our metals to lose 1 to 3 electrons than to gain them because it's based on how many valence electrons you have. And our metals tend to have either 1, 2, 3, or sometimes 4 valence electrons. If we want to figure out how many electrons are going to lose, meaning what their charge will be, we find them on the periodic table and we just count backwards until we hit a noble gas, and that will tell us what our charge is. Maybe we add a positive sign after that. So you don't want to just write, calcium 2. We want to have 2 plus because the 2 could mean 2 plus or 2 negative. And for our metals, our charge should just equal the number of valence electrons our particular element has. When we're talking about our nonmetals, remember our nonmetals tend to form anions or our negatively charged ions. And that's because it's easier for them to gain 1 to 3 electrons than to actually lose them. These elements tend to have 5, 6, or 7 valence electrons. It's going to be easier for them to gain 1 to 3 than to lose 5, 6, or 7. So if I want to figure out what the charge will be, I find my element on the periodic table and I actually count forwards then till I hit a noble gas so that I know how many electrons it's going to be able to gain, and I add my negative sign in there. So for my anions, or my nonmetals, my charge is going to be 8 minus the number of my valence electrons. So for example, nitrogen has 5 valence electrons. So if I do 8 minus 5, I get 3. And because it's a nonmetal, it's going to be a 3 minus charge. Okay. Today we're going to be looking at making compounds with our ions, and we're going to be practicing naming them. So just a quick little side note for you here. Ionic compounds are recognized by high melting points and their ability to conduct current when dissolved in water. You guys have previously answered that question about ionic compounds on a brain pop. Okay, and there is a YouTube video in here that you can watch. It's the conductivity of ionic compounds in solution, and you can watch that, at your leisure. Okay, so if we're going to make ionic compounds, we want to keep a couple things in mind. First, it has to be a metal and a nonmetal to make an ionic compound. Okay, we have to be able to get to that net charge of 0. Metals have positive charges, nonmetals have negative charges, so we have to be able to balance them out. We can't have something with a 2 plus and something with a 3 plus coming together because they're not going to be able to cancel out to get to 0. Okay, so if it has ions, there must be positive and negative ions present, and the number of cations and anions have to give us a charge of 0, and that's the procedure we're going to be looking at today. So for example, if we look at sodium and chlorine, it's a very basic compound, one we're familiar with. The ion for sodium is going to be Na plus. Sodium is in our first column. It has 1 valence electron, so it's going to lose 1 electron. Chlorine, on the other hand, is our halogen column. That's our group 17. They have 7 valence electrons, so it's going to gain 1. So notice it has a +1 and a -1 here. Okay, so we have sodium and chlorine as ions. So technically that's the chloride ion. So the process by which we're going to make a compound is called circle flip. So what we're going to do is we're going to circle the charge on each of those elements. Notice I'm just circling the charge. I'm circling the positive and the negative. If there were a number in there besides 1, we would circle that as well. Flip is going to involve flipping them diagonally down. Okay, so the 1 from the sodium goes to the chlorine, and the 1 from the chlorine goes to the sodium. Now I am only flipping the number involved. I'm not actually going to be moving the plus or minus down to the bottom. And you'll see that when we look at our compound. Notice that in this compound, I do have 1 sodium and I have 1 chlorine, which is what my circle flip told me. But I don't see that positive or negative anywhere in there. When I have a compound, I don't want to see a plus or minus charge at all. Okay. So we're going to look at a couple other examples. So magnesium is in column 2. It has 2 valence electrons, so it's going to make a 2 plus charge. Chlorine is, again, group 17. It's going to make a 1 minus charge. So we're going to circle each of our charges. We're going to flip them. Okay. The 2 from the magnesium is now going to go to the bottom of the chlorine. The 1 from the chlorine is going to go to the bottom of the magnesium, and I end up with MgCl2. Okay? And again, the reason we're circle flipping is so that we can balance out our charges. Next, we have lithium. It's a +1 charge. Sodium is a -3 charge. I'm going to circle each of my charges. I'm going to flip them. So hopefully you can look at this and say, all right, that 1 from lithium is going to go to the nitrogen. The 3 from nitrogen is going to go to that lithium. And I make Li3N, or lithium nitride. Okay. So we have 2 additional problems here. Okay, so I'm just going to talk you through them quickly. Calcium makes that Ca2+ ion. Chlorine is the 1-. Again, guys, if at this point you have not located a periodic table, I would highly recommend doing so. Okay, we're going to circle each of our charges and flip. Okay, so the 2 from the calcium is going to go to the chlorine. The 1 from the chlorine is going to go to the calcium, and I make CaCl2. For magnesium and nitrogen, Mg is a 2+ and nitrogen is a 3-. Circle, circle, flip. We end up with that 2 going to the nitrogen, the 3 going to the magnesium, and we have Mg3N2, or magnesium nitride. Okay. If I want to name these compounds now, okay, I'm going to identify the ions that make up each formula, indicate the charges, flip them, and make a formula. So barium, when I find it on the periodic table, is Ba2+. It's an alkaline earth metal. Fluorine, which is our element, okay, notice it's fluoride here because it's the anion naming, is F-. It's our halogen. So now if I want to make a compound with these, I'm going to circle, circle, flip, and I make BAF2. Okay, so that's all we're looking at with regards to going from name to formula. Okay. Let's do 3 others here. Rubidium would be Rb+1. Chlorine is Cl-. Now, sometimes we might be able to look at this very easily and say a +1 and -1 is obviously going to be RbCl, but we can circle flip as well. Now, here we have a transition metal. Gold has that Roman numeral to tell you its charge. We have Au3+. Sulfide is coming from sulfur, so we have S2-. Circle, circle, flip, and we make Au2S3. For aluminum phosphide, we get Al3+ and P3-. Okay, when we circle, circle, flip these, I get Al3P3. Now, please notice at the bottom that both of those numbers are 3s, which means they can reduce. And we always want to express our lowest reduced possible state. So our actual answer would be ALP. Okay. Now we can reverse this situation. I can give you a compound like I give you here and say, all right, well, what things make this up? And so we're just going to take that idea of circle flip and we're going to reverse it. So I'm going to take my numbers at the bottom. I'm going to circle the 1 that's next to that cobalt, the 2 that's next to that chlorine, and I'm going to flip them back up. Okay. Remember, the first thing in the compound has to be your positive ion. So we're going to make CO2+. The second one has to be your negative. So I'm going to make Cl-. Again, I'm just taking my numbers from the bottom and flipping them back up. And remembering that the first one always has to be positive and the second one always has to be negative. In our aluminum chloride, I'm going to circle the 1 on the bottom and the 3, reverse flip them, and I get Al3+, F-, and that should be a Cl-. Sorry, that's my typo. Now, sometimes we will want to check them. So here, if I circle the 1 and the 2 on the bottom and reverse flip, I get Sn2+ and O-. Now, if we have our periodic table and we look for oxygen, we'll notice oxygen is in group 16, which means it should have 2 valence electrons and have a 2- charge, which just means that this compound had been reduced. So what we're going to do is we're going to get oxygen back up to 2-, but to do that, I also have to double the tin charge. So these are tricky ones. So if you have any problems with these, please see me in office hours and I'd be more than happy to help you. Same thing here. When I flip these back up, I get a +1 and a -1. Oxygen has to be -2, which means calcium has to be +2. All right. The last thing we're going to look at now is what do we do when we want to name from formula to the actual name? Okay. Our cation's always first. Our net charge has to be 0. So here's a bunch of problems for us to look at. So for NaCl, I would use my periodic table to pull it apart, and I would get Na+ and Cl-, and I would name each component. Na+ is the sodium ion, Cl- is the chloride ion, so I call this sodium chloride. Same thing for my next one. I pull it apart, and I get K plus and I minus. I name each component potassium iodide. Okay, here we have calcium sulfide, cesium bromide, and magnesium oxide. Again, I'm naming each component. On this slide, I just wanted to provide you examples of what we have with transition metals. So here, if I unflip my CuCl, I get Cu plus and Cl minus. So that's my copper 1 ion and my chloride ion. So it makes copper 1 chloride. Okay. Here, if I unflip and adjust, I get Hg2 plus O2 minus. This is my mercury 2 oxide. Circle flip, Fe3 plus O2 minus, so my oxygen's good. I get iron 3 oxide. And last but not least, here we have manganese 4 oxide. The oxygen did have to be adjusted in this one, and that's how we ended up with manganese 4. So those are our notes for today. So making compounds and naming them, it is a lot, but we're going to work through it for the rest of the week. So hopefully if you have any issues, you pop in and see me in office hours. Hope to see you guys soon. Bye.